Hello, today we are going to talk about powers and exponents. You have worked with powers and exponents before, but not necessarily with a graphing calculator. So what I want to do first is just go through some basics on how you can use your graphing calculator to work with powers and exponents. Okay, so just so you know, let's go ahead and type in 2 squared. So there are a couple of ways to do it. First, you want to type in the number 2, and then you can hit this button here. It's the x squared button, and that automatically squares your number. You can hit enter after that, and of course 2 times 2 is 4. Let's say you wanted to type in 3 to the 10th power. You can't use the x squared button because that's just for x squared, because that's a pretty popular thing. So let's go ahead and see how to do 3 to the 10th. You will hit the number 3, and then you're going to hit the caret button. This little caret button is right here. It is above your division sign, and that means to the. So we have 3 to the, and then you can type in 10, 10th power, and then hit equal. You'll get a big number. Okay, the last thing I just want to show you quickly is what to do if we have a negative base. So let's say we have in parentheses -3 to the 4th power. It is really important that we use parentheses when they are available, because if they're not there, it's actually a different problem. We follow the order of operations differently. Well, we follow it the same way, but you might end up with an answer that you wouldn't think you would get. I'll put it that way. We'll revisit that concept in a little bit. But parentheses are important, so where are the parentheses? They are above 8 and 9, so you'd hit parentheses, then your negative button, which is under the 3, then you can actually type in 3, then your other parentheses, which is above 9, then the caret button, and then you can hit 4 and enter. So just practice doing that a couple of times. If you need to pause, hit pause. If you're ready to jump into the lesson, you can go ahead and get your notes ready, and we'll get started. Okay, so first things first. Here is a power. This whole thing is called a power. It is made up of an exponent and a base. So it's good to know that terminology. Make sure you know what you're talking about. We use exponents to represent repeated multiplication. There are situations when you need to do 2 times 2 times 2 times 2, and it's, instead of writing it all out, we can use power notation to make it a lot simpler looking. Let's just run through our powers of 2 really quickly. We'll review the special rules when you have 0 and 1 as your exponents. Also, just as a note, 2 to the 3rd power is also 2 cubed. You need to know cubed. 2 to the 2nd power can also be referred to as squared, so 2 squared. It doesn't have to be base 2. You know, that's just the example we are using. But to the 3rd power is cubed, to the 2nd power is squared, and then so on and so forth. What I would like to do now is just go through what the repeated multiplication looks like, and we're going to work backwards. So 2 cubed is 2 times 2 times 2. What about 2 squared? 2 squared is 2 times 2. Okay, so let's just follow the pattern here. 2 to the 1st power would just be 1, 2. And what would happen with 2 to the 0? Well, let's see what's happening with each of these. 2 times 2 is 4 times 2 is 8. 2 times 2 is 4. We just have 2. Let's work backwards here and see what's happening. And if there's a pattern, we can find to figure out what 2 to the 0 power will be. So how do you get from 8 to 4 and then from 4 to 2? Well, it turns out that we are dividing by 2 each time. That makes sense because 2 is the base, and I keep cutting out a 2 as I work backwards, right? So the same pattern will hold true. What's 2 divided by 2? It is 1. Okay, it is 1. So let's go ahead and talk about the rules about exponents of 0 and 1. Any number to the 0 power is equal to 1. Any number a to the 1st power is equal to itself. Memorize. You can always work backwards like I just did to figure out the rules, okay? But it would be helpful just to memorize these facts. Maybe slap them onto some note cards. So if I said, what's 4 to the 0 power? The answer is 1. And again, 4 to the first power would be 4. 4 to the second power is 4 times 4, or 16. And you can see the pattern working backwards here is I'm dividing by 4 each time. Okay, so it works with any base. Let's go ahead and talk about powers of 10 for a moment, because those are also pretty special. So 10 to the 0, 10 to the first, 10 to the second. We just want to look for some patterns again to work efficiently so that we're not doing crazy multiplication with powers of 10. Okay, so 10 to the 0 is 1. 10 to the first is 10. 10 squared is 10 times 10, or 100. 10 cubed is 10 times 10 times 10, or 1,000. Do you see the pattern yet? Take a look at the number of zeros you have in your answer and your exponent. What do you see? When you're dealing with powers of 10, it turns out that the exponent tells you the number of zeros you should have after the number 1. So 10 to the fourth should be a 1 with 1, 2, 3, 4 zeros after it, or 10,000. 10 to the fifth is 1 with 1, 2, 3, 4, 5 zeros, or 100,000. So what will 10 to the sixth be? 1, 1, 2, 3, 4, 5, 6. Yep, it is 1 million. That is so much faster than trying to do all of the multiplication with tens. So with powers of 10, the exponent, and this is with positive exponents, the exponent tells you the number of zeros you have. After 1. Okay, after the number 1. So again, another really important point to note, because it will make our lives easier. So just make sure you get that down. Okay. I'm going to jump to the next page here. Let's say we wanted to take a look at powers with negative bases. So here's where the order of operations comes into play. We need to make sure that we are good with parentheses and when we don't use parentheses. So here we have negative 9 in parentheses squared. Order of operations says that we are going to work with the exponents, and what happens to be squared? The negative 9. So this is equal to negative 9 times negative 9. We know a negative times a negative is positive. 9 times 9 is 81, so that is our answer. Let's go ahead and see what happens when we type this expression into your calculator. So I want you to do it in your calculator first. So you're going to hit the negative button, 9, and then you can hit the x squared button, like I just showed you, or you can hit the little caret with the 2. Hit enter. What do you get? Did you get it? Negative 9 squared. You'll get negative 81, and you might go, what? And this is true. The answer before was also true. So the parentheses make a difference. With the parentheses, I want negative 9 to be multiplied by itself, giving me a positive number. But without the parentheses, what this is really doing is saying, hey, I've got this negative sign out here, but the squared is attached to just the 9. Order of operations says I have to do that power first. So I'm going to leave that negative 1 off to the side for a moment. I'm going to do 9 times 9. That gives me an 81. And then, oh yeah, I'll multiply it by negative 1 to get negative 81. Okay? This is important. I'm showing this to you because most of the problems you're going to work with this year will have negative bases that are within parentheses. So you must write the parentheses down. You must do it. Otherwise, you could potentially get a different answer. So keep that in mind. Parentheses are a big deal. Parentheses matter. Let's go ahead and practice writing different expressions using exponents. Writing with exponents. Okay, so for example, let's say I have x times x times x times x times x times x. How can I simplify this expression? Well, I have all multiplication and I'm multiplying by the same thing over and over again. How many times? 1, 2, 3, 4, 5, 6. So this will equal x to the 6th power. This is not to be confused with addition. If this were addition, it would actually be 6x. So we're working with all multiplication. Let's say I have 10 times v times negative y times negative y times negative y. I want to simplify this. Now, I just want to write it using exponents, so I don't need to come up with any numbers. But here I have 10 times 10, so that will be 10 squared times v. And then how many times is negative y being multiplied by itself? 3 times. So in parentheses, I need to keep that negative y. I'm going to say negative y to the 3rd power. I'm not evaluating. I'm not moving negatives anywhere else. I want to keep the same bases that I've been given. Okay, so this is how you would simplify that expression. What if I had something like this? X plus 3 times x plus 3 times x plus 3. Okay, this is pretty interesting. A lot of people would want to do x cubed plus 3 cubed, but we have to be very careful because these are sums. So I have to look to see like what exactly is being multiplied by itself. So in this case, x plus 3 is being multiplied by itself 3 times. I have to keep it as a unit. My entire base is x plus 3, and that is being multiplied by itself 3 times, so that is to the 3rd power. Again, x cubed plus 3 cubed doesn't work. We could prove it by putting something in for x and showing that we wouldn't get the same thing. So that is not an option. Okay, let's go ahead and just evaluate a little bit. And then we'll call it good. We will do a lot of practice with powers in class. So evaluate, of course, means to solve. It will give you negative 3 cubed. And let's say I give you this, y squared plus 5, when y equals negative 3. And 3 parentheses x plus y to the 4th. If x is negative 2, y is 1. And I'll give you one more, negative 1/2 squared. Remember that we still have to follow the order of operations. Exponents come before multiplication, division, before addition, subtraction. So you really have to focus on your order because it does matter. So hit pause, solve these, and hit unpause when you're ready to proceed. Okay, so let's take a look at the solutions here. We will have negative 27, because we have 3 negatives, for the first one. For the second one, you need to put parentheses around this when you substitute it in, okay, because we want the entire number, negative 3, to be squared. So negative 3 squared plus 5, so negative 3 times negative 3, that's a positive 9. 9 plus 5 gives you 14. And then here, let me do C over here. I have negative 2 plus 1 inside my parentheses. Let me do the parentheses first. That'd be negative 1 to the 4th power. Be careful. Negative 1 times negative 1 times negative 1 times negative 1 is positive 1. It's not 4 or negative 4. Okay, positive 1. So 3 times 1, that's just 3. That was kind of fun. And then negative 1/2 squared. It's just negative half times negative half. We can do that, no problem. It will be a positive 1/4. Okay, I would like you to go ahead and just do a little bit of practice on your own with the entrance ticket. There's an online quiz 491, so go ahead and just try those few problems out. Okay, thanks. I will see you guys in class. Bye.